This is my Omega Race multiplayer game turned into a networking game. Here we have the lobby. When the game first starts, the player either has the chance to create a new local account or sign in with an existing one. For this demo, I'm going to use the Zud account. Once logged in, the player is presented with the menu screen. Here the player has a couple different options using either the keyboard or the Xbox controller. Using the Y button, the player can turn the sound off and on. I'm going to just keep it off just so it doesn't interfere with my recording. The backspace or X button will display the current controls for both Xbox controller users or the keyboard users. The A button will create a new session, and the B button will join an already existing one. You can see here that if I press B with no session to join, I do get an error message and the ability for all the options to come back. When creating a session, the host cannot move until the remote player has chosen to join a session. Once the remote player does join, both ships get the ability to move about, create missiles, lay bombs, play the entire game. Here I'll just quickly demonstrate that I can go through and rotate through the lobby as well as playing a game. Here you can see I can kill the other player, hit escape, I go back to the lobby, create a new game, join it from the other computer. And then I'm right back into it with a brand new game with all reset data. The game's data-driven implementation cannot be seen, but of course both ships are updated locally and their positions are sent to each other using a player position packet. In the change list 118057, I initially had each player sending the inputs to the host machine and then had the non-host machine only displaying the ships, but because of the implementation of the networking example on Perforce, I had switched it so both machines were updated locally and then their positions were sent to each other. When a player wants to create a missile or a bomb, the button pressed creates a packet to be then sent over to the other computer as a signal to then create a bomb or missile as well. Here you can see I can create a missile from the other computer as well as lay a mine. When a collision or the physics update method is called, the appropriate packets are sent using an enum to describe what type of object it was, as well as with the unique ID I have assigned to all gamed objects in the game. The network and prediction smoothing is still a little sketchy, but I simply couldn't get it to work 100% all the way. I tried to look at the example that was in the Perforce, but because it was using tanks that had a interesting implementation as rotation rather than just apply an impulse, I couldn't get it to work all the way. You can see here that if I press the X key, all of your controls pop up with network simulation, packets per second, prediction, and smoothing. Only the host is able to control the different settings, but both machines can see them. So we'll do here, I'll increase the network simulation as well as the packets per second. Move the non-remote player. You can see that obviously it's moving a little faster now, but it is a little wonky because of the packet loss. And then I can attempt to turn on smoothing, which smooths it out a little bit, but like I mentioned, it does not work 100% all the way. Same thing if I turn smoothing off, add in prediction. That's what it is. Thank you.